Hello, everybody. This is Glenn Schultz with the FDT Group. Welcome to our FITS Developer Seminar. So just as a matter of decorum, because we have a full conference room here at Pepperell and Fuchs, and we also have quite a few people on the conference line, about 100 people in total, what we'd like to do is each presenter will go through their topic. When that presenter is done, we'll leave an opportunity for questions for that presenter so that we can keep them close to the topics that were presented. And then at the end of it, we'll also ask for questions. So for those that are joining us via webinar, you can raise questions by typing them on your screen. Please don't ask them on the telephone, just type them on your screen, and our moderator will bring them to our attention when we get to questions. And for you in the room, we'll ask for questions, and I'll probably repeat your question unless you just happen to be close to the speaker phone so that everybody can hear what your question is. So I'd like to thank Pepperell Fuchs, and particularly Thomas Vesters, for arranging the facility and hosting us here today. For those that are on the conference, unfortunately you missed a nice lunch before the start of this conference, but we're all settled in here and ready to go. So the topic today is FITS. So a little bit about our agenda for today. We'll cover what brought us to this point, how do we get to the point of talking about product lines such as FITS. I'll give you a very high-level introduction of FITS, just an overview, more from a commercial perspective, and that'll really set the stage for all the technical presentations that'll follow. Then we'll talk a little bit about FITS and OPC UA. This part of the presentation will be led by Dr. Thomas Hodlick. Then we'll go through the complete FITS technology stack, what we've done for prototyping and demo, and so on. And that'll be led by Dr. Michael Gunzert. And then we'll wrap up with a little bit about the product development roadmap, just to kind of give you an overview of that, and then conclude with questions and answers. So a little bit about the history of FITS, what really got us to this point. Many of you have been active, and this will be old information for you, but not everybody has been part of the various activities leading us up to this point. So really, starting before 2015, we started receiving customer and vendor inquiries as to what we were going to do with a mobile solution for FDT. As you may well know, FDT today is pretty much bound to a desktop application. FDT2 gave us client-server capabilities, but not true mobile unless you were on a Microsoft platform. So because we were getting these consistent inquiries, our technology marketing group in October of 2015 launched an extensive market survey to ask the vendor community, the end user community, consultants and university folks, what is it when you say mobility? What specifically is it? What do you want to do with it? What platforms are you talking about? How would you use it in your workplace environment? And so on. We did this two ways. We did a web survey, and we got about 270 participants there, so pretty nice broad sampling. And then we also picked some customers and went into their facilities. We had a professional facilitator for those meetings. We asked basically the same kind of information as the web survey, but then had an opportunity to walk around their plant, talk about their specific issues, hear what their vision of the future was. So it was a rather extensive exercise to really collect all the requirements across the different sectors. Then in July of 2016, we convened a technical committee of mobility experts, people that really knew about mobility. So not necessarily FDT, but knew all about mobility. HTML5, JavaScript, webs, WebSockets, browsers, etc. A whole panel of experts. At the same time, technology marketing basically pulled together the master set of requirements for what would become known as FITS. And we'll get into that in a minute, but they put together the basic requirements in July. Then October of last year, we formally launched the FITS concept. We did a little trial presentations around the world to see if it was resonating with what people had told us about mobility and so on, and we received rave reviews. So we launched it formally in October, and at the same time, the board of directors for the FDT Group funded the FITS activity and put a very tight timeline on the whole package as well. So that really formally kicked off FITS for us at that point. Then this year, in April, we began a prototyping activity, and this was the result of the mobility experts saying, well, if these are your requirements, and this is what FDT does, then here's our recommendation in terms of the technology stack and the architecture that you should probably use to do this. So in order to validate that, we've been going through some extensive prototyping exercises, and we'll get into the details of that in just a little bit. I won't go through the questions. We actually had published the questions and answers some time ago. You can find them on the SharePoint site if you're looking for them. But we asked people, for example, what platform? When they say mobility, what specifically do you mean? Do you mean a phone, a tablet computer? What do you mean? And we got a wide sampling of that. We asked what operating systems you were thinking of, and we were really hoping one operating system would just dominate the conversation. It didn't. It was pretty much even between Windows, Android, and iOS. So we really got a great deal of market data that allowed us to put some specific definitions as to what FITS is. So with that, let's get into a little bit of the overview of FITS. So today, this is our current architecture for FDT2, and this diagram is taken right out of the FDT2 specification. So this is the standalone desktop version of FDT, which is probably the most widely deployed topology for FDT. By far and away, the majority are these desktop standalone applications. And what's notable here, just in terms of looking at this, is you've got the frame application, but the DTM is split into two parts. There's a business logic part of the DTM, and then at the top of it, there's the user interface part of it. And notice that the two parts of the DTM don't communicate directly with one another. All that communication passes through the frame. That was a relatively new piece of the architecture for FDT2 that came out 4 years or so ago. That the DTM would be split in these two pieces and communicate through the frame. That was critical to another requirement for FDT2 at the time, which was the ability to run a client-server architecture with FDT2. And some of the FDT members have deployed this type of architecture that you see here. So in this case now on the bottom, you've got the server running part of the frame, and it's holding all the business logic of all the DTMs. On the top of the diagram is the client, and there can be multiple clients distributed throughout the enterprise, and a piece of the frame is up there, as well as the graphical user interface for the DTM. So that's the basic architecture. In FDT2, we didn't specify the network communications, how those two pieces would communicate to one another. That we didn't have to go that far in the specification. So what this does, though, is it basically implies a thick client, because this architecture, while client-server, is still really a Microsoft-centric architecture, because all of the code that was written for the UI for that DTM is really Microsoft-based, Windows Presentation Foundation-based. As I mentioned, the communications between the two parts of the frame and the network are really up to the vendor to decide how they do it. And that really also implies then that the client and the server are probably a proprietary combination. You can't really go buy a client from one vendor and the server from another vendor and put it together. It's likely not to work. Most customers would not do that in this scenario anyhow, but it simply, by the way it was architected, would probably not work. So that's today's situation. So if you take this picture of the FDT2 client-server architecture where you split that frame, and on the bottom you have the business logic and a part of the frame, and on the top you have the frame and the user interface, we take that to step into the FITS architecture. So here you've got that same frame from the lower part of the server, represented, along with the business logic of the DTM. This forms the core of the fifth server. The idea of this is we can protect a good part of the investment. So the business logic that's been developed for FDT2 DTMs, all the well-defined interfaces, the common components even, largely get preserved with this architecture. We're not starting from ground zero. We're really building up from a very well-tested and accepted platform. This will get us, though, to an OS-agnostic implementation. In our first go-around with FITS, the part that will be OS-agnostic are the clients and the apps, and we'll get to those in just a minute. Initially, the server part of it will probably still be Microsoft-centric, but the tracks are being laid so that even that can then be ported to other operating systems. So if somebody in a year or two comes along and says, I want that server to exist on Linux, you'll probably be able to do it. So we are on track to be able to port that over to another operating system as well. And one of the key things we found in talking with the customers about what their mobility requirements are was there was also wide variations in the architectural requirements to support those clients. They didn't just want a server in that facility taking care of those clients. There was a wide variety of architectures that had to be considered. So some people want this thing up in the cloud. They want to host it on Microsoft Azure, for example. Other people aren't so cloud focused. They would rather have it on the edge of their facility somewhere, but serving their enterprise. So it has to be able to serve fog-type applications. Others said, no, a local server in my facility is what I envision. And others said, you know, I could still just do it as a desktop. So the idea behind FITS is it can be deployed in any of those types of architectures. We take that core to FITS and we wrap some things around it. So in the top you see web services, and we'll drill into that from an overview perspective, and Dr. Kunzert will get very much into the details of that. On the left you've got OPC UA. This is a logical extension of the OPC UA work that we've done within the FDT Group, and Dr. Thomas Hodlick will cover that in just a minute. And the control part is largely the control network interfaces you think of today, with a few twists to really support some of the new deployment architectures that FITS has to be able to operate in. So web services side of things will support things like browsers and apps. So you'll be able to access FDT through a standard web browser. You can also write apps to do specific functions that can access the functions of data that's available in the FITS server. The OPC UA side is standard enterprise integration. You can also use OPC UA for some of the same things that you can use web services. So depending on where the customer's technology preferences are, you could write a custom client using OPC UA interfaces, or you could write that custom client using web services interfaces. And some customers will make that choice for us. Others will just say, as long as it works, I'm fine. On the control side of things, as I said, think of this as our typical control networks with all the nesting and tunneling and everything that we well know, but with some additions to be able to handle these different architectures, and we'll take a look at that in just a minute. So let's look at it from the client, from the mobility side of things. So we have direct support for things like browsers. All the standard browsers will work with it. Nothing special is required. We'll expose web services APIs where people can write applications that do something other than what a DTM itself would do. You can use those same interfaces to write full-blown custom programs. It's also possible, depending on the topology of that customer, they may use those web services to interface to other business systems. Not a typical use case, but absolutely nothing preventing it. From a connectivity side, all of these mobile clients can come in any way that you can get connectivity. So whether it's through conventional Ethernet, whether it's through Wi-Fi, 4G, LTE, or anything else that comes along, 5G, whatever, as long as the mobile device supports it, it'll work with the fifth server. Security is a big deal, especially when you start extending your architecture wirelessly. It becomes even more of a big deal. And so we've got the security layers in here to address that using well-established industry security standards, and we'll show you a little bit more about that. Just as a thought provoker, we talk about apps in this environment, and I think we're also used to seeing DTMs and what they do and how they do it, that sometimes it's hard to get out of the box. So we put together a fictitious app just to give you something you might do in the area of apps. So here you've got something for a maintenance person. They're out with their smartphone, out in the facility somewhere, and they see an asset that they want to do some work on. That asset probably has an asset tag on it to identify it. They could either key in that asset tag in that dialog box that you see there, or if that asset tag has a barcode on it, they could just as well, with the camera on their phone, take the picture of the barcode and it would immediately populate that field. Or maybe they're a little bit more advanced and their asset tags are actually near-field communication tags. So all they have to do is get near the tag and it populates that field. But in any case, notice what's different. Compared to FDT today, where you're browsing a topology, finding a specific instance of a device, and so on, here you're just entering the asset ID and you get to it right away. But also, in terms of just a little different workflow, notice the options that this fictitious app gives. You could just launch a conventional DTM and start working with the DTM like we do today, but maybe there's some other things. Maybe there's just shortcuts. Maybe the person's just questioning, is this thing even working right now? Because it looks odd. Something doesn't look right. So show me the current process value. Just a real quick reference. Or maybe they're wondering, is there any health flags on this thing? Is there any maintenance issues popped up? Or maybe they've got to do something completely unrelated and all they're really looking for is the manual to that particular device so they can look up something. So notice this app does, in some sense, what DTMs do, but organizes it to a workflow of a maintenance person and just makes it more accessible. Same data, same DTMs behind the scene, etc., but now you can start to see the value of apps. So from that perspective, if I were selling this app, if that was my product to sell this app to tag on to fifth servers, I'd start to advertise, hey, your maintenance people can work smarter, they're going to reduce the mean time to repair, your facility will be more available, etc. It just helps with workflow. I mentioned security, and I think Michael will get into this a little bit more when he talks to you about the prototypes and so on. But on the outside level of security, we start with encryption, and we use encryption that's well accepted in the industry. So if you're hitting it with a web browser, you'll be using TLS, which underlines HTTPS. So when you're on your banking sites or whatever, you're always looking to make sure it's a secure connection. Same kind of topology here for our connections. But the difference will be we can also validate the certificate going the other way. So normally when you're communicating with your bank, you're looking to see, are you on their secure site? Do they have the right certificate? With FITS, you'll also be able to look the other way. Does the device that I'm about to talk to have the right certificate? Is it allowed in this architecture? But it's the same mechanism. And then similarly for WebSockets, you don't often hear it, but there's an exact parallel, and it's called WebSocket Secure. So you add an S to the WebSockets, and you get the same TLS encrypted connections. So we've got a very hard outer shell to that. Once you get inside of that, you can authorize the device itself. So maybe you're a facility that says, okay, we love this mobility stuff, but they're only going to be our corporate tablets. Nobody's personal phones, nobody's visitor tablets, none of that stuff is going to be allowed to hit our server, even if they know the password. So you could enable that level of capability. Then we have the user authentication, just like we always have had. So now the user themselves has to identify themselves and get their privileges within the DTM and frame. And then finally now you're down to what's actually making this all work, and the way in that protected core of things is HTML5, JavaScript, and so on. And I'll let Dr. Kunzer talk to you more about some of those details. So again, we're using very standard industry security mechanisms. We didn't invent anything new. These are time-proven, well-accepted by security experts, and so it should reflect well in the marketplace. A little bit on the control system side, this diagram is probably the beginning of realizing that the topology of FITS deployment is dramatically different than what we think of for a topology of a desktop application. So in this diagram, you've got one instance of a FITS server taking care of multiple facilities, one of which is local to it, and the rest of which are remote to it. Now, what we learned very quickly in this space is we do not get to pick the methods of communications to those remote plants. Most customers have made their technology choices already, and they're going to be enforced by their IT department. So in the lower case, in that bottom diagram where it says VPN, that might be, for example, a customer that says, I'm not letting you into my industrial control network unless you come through my Cisco VPN connection to get there. That's the only way you're allowed in. So in the case of FITS, there would be a gateway DTM sitting up at the server that's of a VPN DTM. So it'll handle the VPN setup with the Cisco firewall. And so once it establishes that communication, it's as if you're sitting there local in that plant with that control network. Another variation we're starting to see more and more of, and it is kind of strange for those of us that have been in the industry for quite a while, is MQTT. This was an old protocol that was designed really for remote data access from slow network connections like dial-up lines. That's what it was created for. And it almost died off. And then all of a sudden, when the IIoT conversations and Industry 4.0 conversations started getting serious, people said, hey, this is maybe a viable protocol to move data from one plant to somewhere else. And so there are actually people starting to advertise what are called edge devices that use MQTT. And an edge device would essentially be a specialized router that takes whatever protocol is running on the industrial control side, converts the communications to MQTT for the remote site. Whether this becomes commercially viable in the long term, I think we'll have to let some time play out, but to ignore it would not be the right answer. So in this case, if it's an MQTT-based facility, all we need is an MQTT COM DTM sitting up there at the server. Okay, the direct connection just above that is obvious, just like we do today. Nothing special there. And then another area that's becoming an interesting one is all the web-based analytics, the big data kind of things that are really just starting to hit their stride. There have been people advertising them, but I think the end user community is just starting to figure out what these are capable of and what to do with them. So I think it would be wise for us to support communications with those types of big data networks as well, and that could be done typically through a protocol called AMQP. That's the Microsoft protocol for their Azure Analytics. There may be other protocols that emerge, but you can see we're basically relying on our well-established annex procedure, write a COM or gateway DTM, and you're up and running. Just using it in a different fashion to get to remote facilities. So what this means is once you've established that connection, all the tunneling, nesting type things that we do today will work perfectly and as seamlessly as they do today. You'll have no sense that that's a remote facility. You, of course, can do the traditional direct connections. All the remote connections can easily be secured with these protocols. Talking to just about any type of remote gateway, firewall, router should be possible from what we've been able to determine in the state of the market today. And a single server can definitely then serve multiple facilities. So this is a scenario where the customer says, put a server in the cloud, That way, if I need to scale up the server in the future, all I have to do is order more scale from my provider, and it's immediately available. Other people might say, no, we have an in-house cloud solution. We're going to put it in the fog. Same answer there. So it scales nicely across all those applications. A little bit on the OPC UA side of things. I think a traditional use case that we see in the marketplace is connectivity with things like ERP to be able to move production data up into production and control systems and scheduling systems. We're not doing anything special, as it were, with OPC UA. We're fully supporting the OPC UA specification. So our communications here are secure as well and follow the well-accepted OPC UA security standards. You could connect to anything with OPC UA. You could add a PLC on that side of the connection. It could be ERP, it could be CMMS, just about any type of business level application. We will be supporting their publish and subscribe standard, and Dr. Hadlick will talk about some of that. And then you can exchange real-time plant information, you could exchange asset health information, really anything that's inside of that FIT server made available through the DTMs can be communicated through the OPC UA connection. And traditionally, we think of moving data out of the server through OPC UA to something else, but in reality, you can develop use cases that go the other way, where something drives data into the FIT server to enable either a configuration or a status change or something along those lines. So just to kind of wrap it up from the overview perspective, if you envision this in sort of its full form, you have a FIT server sitting up there in the cloud, serving multiple clients, and it could be browser-based clients, it could be apps running on tablets or phones, it could be specific programs that have been written to interface through that methodology. On the bottom, you can see you can support multiple plants, all through secure connections. And of course, with OPC UA, there's even fairly off-the-shelf connectivity with applications like SAP and others at the ERP level to be able to integrate that type of connectivity. So that's the commercial overview, if you will, of the FITS architecture. Just pause here, and I'm going to ask our moderator, too, to just come on the line and let us know if there's any questions that anybody's typed into the remote viewing sessions. Are there any questions?
Yes.
Any questions at this point? I know you want to get into the meat of it, so you probably want to move right on. Katie, anything from your side?
Nope, nothing.
Okay, thanks. Very good. Well, let's get into the meat of it. I'm going to turn the audio over to Dr. Thomas Hadlick, and I'm going to do my best job of driving his PowerPoint since we're in different countries as we do this. Are you there, Thomas? Okay, I think for the sake of everybody on the call and in the room, we might just switch presenter orders here and move on to the prototyping and things. Are you ready, Michael? Can we bring you up? So Thomas, we'll come back to you if you can hear me. I'm just going to skip ahead here on the presentation.
Yeah, welcome everybody. My name is Michael Gunzert from CodeWright, and I'm going to talk about FITS architecture and prototyping. So, a short overview of the presentation. So I'd like to start with a short introduction, then talk a little bit about, so just briefly about requirements and constraints that we had, basically from the technology marketing, in order to set up the scope for this development and prototyping. Then I'm going to talk about mobility architecture, so how we designed this now prototype. And following that, I will explain a few things how this works. Then I will also have a short demo. Therefore, I will need to switch the computer, so this will probably take 1 or 2 minutes. And then coming back to the presentation and tell you or give you a summary regarding the status of the prototyping and some outlook. Okay, so let's start. Introduction. Yeah, regarding mobility, Glenn already told us a little bit. So what are the goals there? Just to repeat this here again. So what we would like to have is FDT applications for different use cases and on different kinds of devices, mobile devices. And therefore we would like to use standard web browsers that are available on these devices. So for example, to access the devices, the DTM of the devices, and do commissioning, for example. Also, we would like to be able to provide native or hybrid apps on these mobile devices that really can make use of all the features of these devices. And this could be apps for which are very device specific, that come from a device vendor, or also from a frame vendor, for example. And a typical use case is here what can also introduce this kind of maintenance apps, which can deal with one specific device or also with any device in the plant. Okay, that's about the introduction and goals. So next is requirements and constraints. So what were the primary requirements and constraints here? First, let's talk about the constraints. So we assume that the mobile devices will always be connected to a server. So we will always have network connectivity via wireless LAN or LTE or 5G, any kind of network. So this is a primary constraint here. Then target users will do mostly commissioning and maintenance activities by using these mobile devices. So this means, first of all, we do not require to be able to build up new projects, to extend projects, but we need, for example, the ability to navigate through a project and to access the devices that are already set up there. Then also the FIT server has always full access to the control networks. Also this is an assumption here or a precondition here that this is established at all times or can be established on demand. And the solution should be based on FDT 2.0, so on our solid basis of FDT 2.0. So we would like to use existing interfaces, we would like to use existing DTM business logic, and this also implies that there is no direct backward compatibility to FDT 1.2.x required here, because with these DTMs you will not be able to use these new mobility features. And also, so it was not a goal to design or test here new DTM features, but we would like to be able to use all the features that are available today. So requirements. So we want to be able to connect multiple clients at a time to a single server. said, so multiple applications, mobile client applications, also on different devices or even from different vendors should be able to work with a FITS server, and this probably also from different vendors. This requires basically that we need to specify the interface between clients and servers to use this FITS web services. Operating systems. So the server, it's still based on Microsoft Windows operating systems, and clients will be based on, could be based on Android or iOS or also Windows or other operating systems. Nested communication should work as today. We want to support basically all FDT network topologies and a number of devices. All DTM features, functions, graphics should be available, should be able to support them. And of course also OPC UA needs to fit into this picture, and OPC UA may be used for other applications or for other use cases in parallel. Okay, then let's introduce this mobility architecture. So how does this look like now? So first of all, this is a picture here of what we call a conceptual architecture. So here we see different clients. In the middle, a client could use a standard web browser, or we could have a mobile app running on a different operating system, and they can connect to the FITS web server via the newly defined FITS services interfaces, so the FITS web services. In parallel, what's also possible, what we also thought about, is to still be able to support desktop applications, and they can also be connected to the FITS server. In this case, we use a different interface because it's simpler in this case, and on these applications you would be able also to support the new DTM user interfaces, which are based on HTML. I will explain this a little bit more later. Okay, then on the server side, we see we have three components here. So on top there sits the FITS web server. The FITS web server is connected to the FITS server components. This could be common components in future that can be used for different FITS servers from different vendors, and then of course we have our DTM business logic, which is connected to the normal available FDT interfaces. So if we look into this architecture in more detail, so it's specifically for these server components, then this would look like this picture. So we have more detail in here, and so we see that these server components consist of several different components, and I will explain this in the next minutes. And also the DTM part, we see some more details here. We see there is a new DTM, what we call a DTM Web UI. It's basically HTML5 based user interface for the DTMs, which can then be hosted either in a browser or in a integrated or native app which has the capability to host these users. Okay, so let's dig into the details. So first of all, we have a DTM that we want to extend and we want to use HTML5 based user interfaces. So this is what we call a DTM with web UI. So how does this look like? So first of all, the DTM business logic is still based on FDT 2.0, respectively 2.1, so the existing interfaces. There is nothing changed here. It's not needed to extend the FDT interfaces at the business logic. So we can reuse that. In order to make this new user interface available, we need to provide a new DTM UI manifest that describes the type and location of this user interface. The user interface itself, DTM Web UI, is provided as a set of files, which could be HTML5, CSS, JavaScript files. You could also use different, for example, JavaScript-based frameworks like Angular, JS, or similar frameworks to develop and deploy these users. In the prototype, this user interface is deployed just in a zip file. Whether we will keep this in the final specification needs to be discussed, but this is the decision we took for the prototyping. Now, if this user interface is hosted in a browser, it can use the already existing and defined DTM user interface messages, so that is possible to use these messages. You could also define your own or additional DTM UI messages in the business logic in order to support some new user interface, but it's important that this does not need any new FDT interface. So what's also possible with this concept is to provide additional DTM-specific kind of web services. So therefore, you need to define your service-related UI messages and implement some additional service-related business logic to your DTM business logic. And then you could use these services, for example, by your DTM-specific app. Okay. So that's regarding the DTM part. So we also see here that, of course, the DTM is also based on the DTM common component. This is also unchanged. And in addition, in order to make the development and deployment of the DTM Web UI easier, we have also created as a prototype what is called this FITS services here. This is a kind of small framework that provides an easy access to these UI messages. So therefore, it's rather easy to use. Okay. I will explain this a little bit more detail later. So let's come to the next component here. This is the FITS core server. The FITS core server is basically implemented as a background process, so it could be implemented later or deployed as a Windows service, for example. So currently it's just a console application, the prototype. It has access to a database where the project data is stored. And in order to host DTM business objects, it spawns FDT2 runtime processes. these processes actually load the DTM business objects. Okay, we can have multiple of these processes, and each one can host one or more DTM business objects. So this is in order to use this for load balancing, for example. So this process could even run on different machines, so it's quite flexible and scalable even to very large projects. Okay, the next component to explain here is the FITS web server. FITS web server is connected here to the FITS core server via an additional component here, which is called the client component. So you can think of this as just a proxy for the client, which provides a .NET API to the client. So the FITS web server integrates this client component and provides the FITS server web pages and of course also the FITS services, web services. Prototype here is implemented in ASP.NET. Other implementations would also be possible. This was prototyped in ASP.NET. Maybe in future ASP.NET Core would be also an option. And the DTM web UIs are integrated into these frame web pages via iframe. Also the DTM web UIs use a WebSocket interface. Defined or decided to use WebSocket here as a transport layer. Also I will explain a little bit more about this later. Okay, now for a desktop application, so if we want to provide a desktop application based on FITS, this would not use the web server, or not require the web server. So the desktop application can be directly connected to this client component, and it can use what is called here a FITS component API. You can think of this as a kind of common component API, defined by this component. And the FITS services layer that is used by the DTM web UI in this case would be automatically replaced by a corresponding adapter, so that this automatically works, and as a DTM developer you care about this. So you can also use this client component to access the FITS server. Desktop application can also host the same UI. This adapter replaces the WebSocket interface. Okay, any questions so far? Move on with the next part, and I would like to explain in a little bit more detail how this works. So first of all, some important decisions that we took during the prototyping. We had some intense discussions in the project group, and we also tried different ways. And this is our decisions where we came to. So the first one is, and this is maybe the one major decision here, to use WebSockets as a bidirectional transport layer. Why did we do this? Okay, so for FDT use cases, we somehow need a bidirectional communication. at least we need the ability for the server to also send events to the client. This is not possible by using standard HTTP. There are some mechanisms which can provide this, to use polling and long polling. Also, we have evaluated, for example, server sent events, and to use this together with REST services. But we came to the conclusion that WebSockets is the most advanced technology here, the most advanced mechanism, and it's also supported by all major browsers today. So the only exception we found there is Internet Explorer 8, which does not support this. But later versions like Microsoft Edge browser. Okay, so the second decision, was to use REST services. So we would like to use REST services because they are commonly used nowadays for many web-based applications. And many people, also developers, are familiar with REST services. But standard REST services are based on HTTP. And so we tried to combine this REST concept and REST-like services with WebSockets. And this can be done. So in this case, we need an additional kind of high-level protocol. We need to define a protocol based on WebSockets, which is required for sending and receiving REST calls over WebSockets. And this is what we did. Okay, then third thing here is to use standard JavaScript WebSockets on the client side. So this is built into this FITS services framework. This is in order to simplify the usage of WebSockets for clients. So therefore, I created this little framework. This is actually implemented now in TypeScript. TypeScript is a kind of typed version of JavaScript, so it can be translated to JavaScript. And we also use a JavaScript modularization system in order to make this framework as a kind of isolated component, which can be loaded. Okay. Now we look at how this actually looks like in terms of the services, how they are implemented. So how does a request from the client to the server look like? So in this case here, so each call from the client to the server is wrapped into a FDT FITS request object. So this is a defined object that can then be automatically translated also to a .NET object. And it contains the following information. So it contains an identifier, which is used to identify the callback with the received response, so that the client is able to do this. It contains the REST command, including the REST resource URL, and also, of course, the data we want to send, if we want to send it. So the interesting thing now here is that these objects, as I just said, are automatically serialized. We can automatically serialize them and deserialize them by this FDT FITS framework. And they are serialized into JSON format. And in this JSON format, they can be transferred via our WebSocket transportation layer. And here you see an example how this, or the structure, how this request looks like. So the ID here is a geo ID. Then we have this REST resource URL, which defines the resource that we want to access. for example, a device can be a resource or a function of a device. Then we have the REST command, and we have some additional data. And this in turn can be an object. So for example, this could be a UI message. Okay, now on the other side, we get the response back from the server to the client. And again, we have here an identifier. To identify that the response corresponds to this request that we have sent. Then we have error information inside here in form of this FDT fit error object that we have defined. And again, some optional data. So for example, this data would be a UI response message. Okay, and here again, we have the format of this. There is one additional field here, which is interesting. This is event. So in this indicates, so if this is true, this indicates this is an event which is sent from the server to the client. So this is something that the client has not requested, but it can just be sent by the server. Okay. Then this is the kind of how these services get documented. So this is the style that is also used for REST web services. So we use the same style here. And this is just an example which shows the service for get project information. And here we see that we get back, so if we request this to the certain resource, we get back a list of project nodes, and these project nodes contain a number of items here. So this is for each device, the label, the device ID, the system tag, the manufacturer, and so on. So this is the kind of style where how this gets documented. Okay, now how does it actually work? So first, if we open or we want to open such a DTM in a browser, so first we connect the client to the FIT server. Then it loads the initial web page, which is normally a login page, where the user types in the login credentials, and the user is authenticated then in the next step. And if this is successful, then the client requests this FDT project information. And again, this is displayed in this frame web page in any frame-specific way. So, for example, you see the different projects that are available here, and then the user can select a project. Then, next step, the devices get shown, the list of devices, and you can select a device. So then, the user would select in the next step a function of the device. So, for example, a parameterization function. And now at this place, actually the DTM gets instantiated by the server. So first, the server starts this FDT2 runtime process if it is not started already, and it instantiates the corresponding DTM business logic. Then, as I said, the web UI is registered by this DTM UI manifest to the server. This is what the server can look up, which web UIs this DTM provides. And then the DTM web UI gets loaded from the server to the client. register the UI, and then the UI is displayed in the iframe. Basically the sequence how DTM Web UI gets opened in the browser. Okay, and then after the Web UI is registered, the Web UI can talk to this FDT services with the business logic. As soon as the user, for example, closes the tab in the browser or closes the browser, then the FDT web server will recognize this, the connection gets lost, and it can also clean up and unregister the user interface. Okay, so this is an example of such a web UI, and this is what I will also show now in a short demo. So therefore I need to switch the computer, so this will take 1 or 2 minutes. Any questions so far?
Ask Katie if there's any questions.
Katie, are there any questions from the participants?
Yes, we have a question from Georg Schroer. He wants to know what he would need to do to create an app based off Xamarin.
Sorry, based on what, please?
The Xamarin.
Xamarin?
Yeah, Xamarin, okay.
Yeah, okay. So with Xamarin, so he would need to know the FDT web services. Yeah. So actually then our specification or draft specification of the FDT web services, and this can basically be used by any kind of client. You can also use this by Xamarin. This is not something that we have prototyped, but this should be possible. So, any other questions?
That's all.
Okay, then I will switch over to the demo.
Oh, I'm sorry. He has a follow-up. So I'm not necessarily bound to HTML5/Java.
For an app, no. So the a DTM web UI, yes, somehow it must be hosted as a web page. Yeah. But for an app, it doesn't need to. Does this answer the question?
I believe so. I don't see another follow-up.
Okay, now I am on a virtual machine here, and I will just start the FDT core server prototype. So this is now running. And then, yeah, I can start a browser. And connect to this server. Okay, now we see the login page here of this prototype server. In this case, it's not yet made secure or anything, but just as an example. So this is still something to follow. Okay, so we can just log in now. And what the client now does is looking up this project information. So it's now obviously we have just one project here, which is a sample project, and we can select this project. and then, for example, the FIT server can display another web page where the user is able to search for devices or get a list of devices. We could imagine different kinds of user interfaces to navigate or to look for a device. Okay, now we can select one of these devices, so this field device here, and now we see that another process is spawned, and this is this FDT2 runtime process. So we have now selected one device. We want to access this device, and therefore the server knows, okay, now I have to start the corresponding DTM. And as we have not started an FDT2 runtime process yet, he needs to do this first. Okay, so this is now done. The client is registered, and now it also displays the functions, and we can access this function now. Now it's loading the DTM web UI. So this is basically just a screenshot that we saw before on the presentation. This is now a complete web UI for DTM as it could look like. And this is built with HTML5 and Angular in this case. And we can navigate through the tabs here. We can see the parameters. So currently there is not so much available yet. We have still some simulations in there, but for the final prototype, this will be fully functional. But this is just to give you an impression how this could look like, and the same thing I could also show works on a tablet as well. Only thing is that here for the presentation it's a little bit difficult to set this up. Okay, so basically that's it for the short demo. Any questions about this? Eddie, any questions from the audience?
No questions from the audience.
Okay. Good. Then I think we can switch back. Can you make Glenn the presenter again, please?
Absolutely.
Thank you. Okay, now status of prototyping. So what have we done so far? So for the prototyping, we were looking at two scenarios specifically, and we set up some goals that we want to achieve. So the first one is this DTM with web UI for device configuration, basically. So there, one goal was to identify the required generic web services to provide DTM-specific mobile UIs or web UIs based on HTML5. So this is done. We did this. Also, we have this. It's not a final specification, but it's drafted. Take this over. So next thing was to identify responsibilities that should or could be implemented as a common component, as a frame CC or DTM CC. Also this is done. So we have seen these server components as well as these services which belong to DTM. then refine the draft solution architecture. That's also what we did already. In the architecture now, create draft specifications for service APIs and DTM interfaces. That's also mostly done. Some web services are still need to be completed, but basically this is done, we can say. Implement a mobile DTM prototype, also available, and then evaluate potential technical or performance issues. We did some technical evaluations, also performance evaluations. We set the target that it must be possible to achieve a response time of at least 200 milliseconds. So this is something we tested, and therefore we also found that WebSocket is much more, is more performant than compared to use normal REST-based web services. So it was no problem to achieve this 200 milliseconds response time. And identify potential security issues. This is also something we did not do right now. Then for scenario 2, and scenario 2 is basically this maintenance app scenario. Also here was the goal to identify the required generic web services for diagnostic maintenance use case. So we did this. We did also create some draft specifications for this service APIs, and we created draft specifications for this, for one specific app there. Also identify responsibilities. This should or could be implemented as a common component. That's also done. Error scenarios are not really considered by now, just briefly. And also the last point, identify potential security issues, is open. So results so far. So we have some specification drafts. So this means draft definitions of the required extensions to FDT2. Drafted and it's also implemented. Then draft definitions of fit web services, at least these generic parts. And we have several prototypes. So we have prototyped this FDT2.5 interfaces and data types. Actual prototypes are based on this. We have this prototype fit server, both as a desktop and a web client. I didn't show the desktop client yet, but that's also available. And we prototyped this DTMCC extensions and this web UI DTMs. Okay, Outlook. So what is still done? Still completion of this prototype implementations that were done by M&M and CodeWrites. Then also what is ongoing is also validations by other companies, so that are represented here in our project group. So they also wanted to create some DTM prototypes. Still ongoing there by Schneider, Yokogawa, Hilscher, as well as Turk. And for the maintenance app prototype, we still need to do the implementation of the fit services for this maintenance use case. Prototyping should be finished by October. Okay, and then we propose to have this separate security assessment and risk analysis based on the architecture that we have now created, maybe as a separate project, because some more things to do. Okay, that's basically all. Then, thank you. any questions left?
We have a question online from Friedrich Wagner. He wants to know if calling a device a specific UI means that all necessary communication DTMs will be loaded automatically on the server when using a nested communication.
I didn't understand it completely. Could you repeat the question, please?
Sure. Calling a device a specific UI means that all necessary communication DTMs will be loaded automatically on the server when using a nested communication.
This would need to be done, yes, by the FITS core server. So this is done.
But you have defined the project before.
You have defined the project
it's not
before. Yeah.
in a way that it just comes out of the air. The topology, so the topology needs to be defined. It is defined in the project, and then it can be loaded.
Yeah. Right. So currently, for example, for this prototype, it is possible to create a project with an FDT2 frame, then export this project, and then the project can be loaded by this prototype server. And it's right, as soon as you access one device DTM, all the parent DTMs also get instantiated.
That's all the questions at this point.
Michael, can you hear me?
Yes, Thomas.
Okay, I have a question. You showed the DTM user interface, and my question is, did you test this user interface on a mobile device like a phone or something like this? Is such a user interface automatically usable on a small mobile device?
This particular user interface is not usable on a phone because it was not designed for a phone. So actually we had designed this user interface before, and so it was designed for tablets or laptop computers. On a tablet,
okay.
For this, we will have a design guide, Thomas, which will be able to have UIs which are responsive to the environment.
Yeah.
Okay.
Yeah.
How can I use one FDT frame to generate the project? Will there be some kind of common exchange file format so that I can use one FDT program like Textware or whatever to generate the project and use it on the FITS?
Yeah, we have. Okay, the question was whether there is one common exchange format for FDT projects, so that I can create a project on one FDT frame and then import it to another. Yes, this is defined, and as a XML based format in FDT2, and this can be used and imported. Yeah. Currently in the prototype, so not sure how we will do this later on, but this is how it's working in the prototype right now. Any more questions?
None from online.
Okay, thank you. Thank you very much. Then I will pass back to Glenn.
Okay, thank you, Michael. Very much appreciated. Thomas, we're going, if you're on the line, we'll wind back to your slides, and I'll push the buttons, and you can talk.
Okay, thank you.
Okay, you're all set, Thomas.
Okay, so the update of the slide is pretty slow, so I hope people can hear me. I'm talking from China. I'm at an IEC meeting in China, and for some reason I've got invited to do this presentation. Actually, Manfred Brill is there, so if the friendly telephone services from China break down, Manfred, I hope you take over. So Glenn has already introduced the OPC-UA project and the targets. One of the targets is to expose information to higher level applications, so MES or ERP level applications. So the next slide basically talks about which info we want to expose. Could you? Okay. So yeah, this slide basically is based on a picture already in FDT2 specification. The DTM exposes a lot of information about the device, and the last part actually missing that what is shown here is the DTM not only exposes information about network, about the device type, about parameters, but also about the current status of the device. Next slide, please. Could you? Okay. So also FDT2 specification already showed that we intended to use DTMs in such an environment. So the idea is that the DTM is integrated into the frame application. The DTM talks to the device and then exposes this information to an OPC-UA information model. And basically the OPC information model is accessed by the OPC-UA client, and when the client reads information from the OPC-UA information model, the read is redirected to the DTM, and if it's an online read, it's redirected to the device, and then the information is returned back to the client. So this is basically the goal that we have. Next slide, please. So from all the information that the DTM exposes, we at this point of time we are able to expose a subset of information. So we are at this point of time not able to expose the I/O signal information. The network information is not supported. We have no support for the DTM user interface, and also documentation of the current data is not supported. So documentation of current data in FDT terms is called report generation. So this does not work at this point of time. Next slide, please. But I'm sorry, all other information we are able to expose. So we are able to expose. We have implemented an OPC-UA server prototype. So you see this on the slide running in the background. The server loads and prepared projects and exposes the information via an OPC-UA interface. And we have also implemented a specific OPC-UA client that is able to provide a nice representation of the information. So everything that you see in the OPC-UA client is transported via OPC-UA interface. So the project structure is provided via the OPC-UA interface. We can get the device type information, including images and icons via the OPC UA interface, and we get the list of parameters, the documentation, and so on can be provided via the OPC UA interface. So could you go please to the next slide and stop, don't click through. Okay, so basically these I'm listing basically the different information. So here we see the device identity information. This is based on the offline, so on the DTM information interface. So we take the information from DTM information, map it to the OPC UA interface, and are able to transport it. Here, the OPC client provides a tabular representation. Any other OPC client can choose another way of representation. Okay, next step. Okay. So this shows that we are able to provide device documentation. So basically, if a DTM references documents, then so documents can be either referenced via DTM information or as a document function, and both can be supported by the OPC UA interface. And if the reference document is something like a PDF file, OPC UA supports transport of the PDF file, and we are able to open it in the OPC client. The second example that we see here is an web link. So the DTM provided reference to a website, and of course it would be also possible to open a web browser with that website. Okay, next step, please. Okay, so this is the device offline data. So and DTM basically provides via the instance data access to the offline data of the DTM, and basically the offline representation of the device for doing offline configuration and similar. And via the OPC UA interface, we are able to access this information. It's also possible to represent this information in a hierarchical way, and we are also able to not only to read but also to write this data. Next step, please. Okay, and last but not least, we are able to support online access, so it's possible to see the device status. This is actually represented here in the project view by the small round circle below the device name. So the green bar in front of the device icon shows we are online, and the green circle shows that the device is in a good status. And additionally, we are able to observe the online data of the device. So here the device exposes only two values, but okay. Next slide, please. Takes a little while until I see the slide, so I assume it's already visible. So something that we did for Hannover Fair basically was we provided a prototype for support of HTML GUI. So on the the small square on the left side of the OPC UA client is an HTML web page. That HTML web page was transported as a string via the OPC UA interface, and basically it's displayed in a web browser control, and we are able to access the values that are exposed via the OPC UA interface and display. It would be possible to display them also graphically. Next slide, please. This slide basically talks about something that's a big topic currently in Germany and actually also internationally. This is support for smart manufacturing or for Industry 4.0. For smart manufacturing, it will be necessary to provide not only device configuration information for a device or maintenance support, but also it will be necessary to support a device description. And here we demonstrated that if the DTM provides a document which is based on E-class, so you see the E-class document basically is provided like the documents we saw before and is displayed in the background. Then what we can do with that is shown in the next step. So I'm not seeing this, but yes, when such a file is provided, we are able to translate such an XML file, which is just composed of identifier and value. We are able to translate this to a display that shows the value with a readable name together. So the intention of this again is basically to show that with FDT we are able to fulfill certain requirements defined by Industry 4.0. So this is implemented in the prototype that's available. I think Manfred and Philip will demonstrate the prototype later on.
It's not really planned today, Thomas. So, but
okay.
There's interest. We might do it here locally.
Okay.
I don't know.
So.
Question to the prototype, Thomas. Do you have the intention to do the demo in our webinar next week?
Yes.
Okay.
Yeah. So next week on September 14th, we are going to provide a webinar with more details on this prototype, basically also more details in regard to Industry 4.0. And if you are interested in this topic, you are invited to participate in the webinar. I think Glenn can provide more information about when the webinar is organized and how to access this.
Yeah, and there's also links on the FDT website to be able to sign up for that webinar.
Okay. So this basically is result of the project 1 of the OPC UA working group, and recently we have started the second project for the OPC UA working group. So could you please go on? Yes. So actually, chairman for project 1 is Manfred. So in the first step for this project, we discussed what is necessary. You saw before in the slides before that we do not, at this point of time, do not support all information provided by the DDM. So basically, one of the targets for Project 2 was to provide, to support additional information, but also one target of the Project 2 is to support prototyping for FDT2. So at the moment, this actually has highest priority, and also high priority that we see is to support the I/O description and to support access to I/O data. The documentation of data, basically the report generation, we see as medium priority. Support of network configuration or direct access to communication channels is also a topic that we have discussed, but currently we see that with a low priority. And in regard to support of remote DTM GUI, we basically are waiting for the results of the mobility project and decide then, based on the documented results of the mobility project, how we are going to support that. And, okay, next slide. So in the next slide, I'm going to talk only about the high priority targets that we have defined. So prototyping for FDT 2.1, so it was possible to review that the new FDT2 specification, and when you have reviewed the document, you will have seen that there are a number of changes. So one of the changes was a change in regard to starting and terminating the DTM actually that's the wrong word. Basically, FDT2 defines when the DTM goes online, then the DTM can execute a device type check. And with FDT 2.1, we defined the ability for the frame application to control the execution of the device type check. So that's basically something we want to test, because the OPC server, when the device is not accessed online, it shuts down the DTM and loads the DTM again when an online value is threat. And when this happens very often, we experienced problems if the DTM executes always the device type check. So this new behavior is very important for us. Another topic that we want to prototype is support for static functions. FDT 2.1 defines a new approach for static functions, which actually makes static functions executable. And with the OPC server prototype, we want to test that. Also, a topic is support for array data types. So FDT 2.1 has introduced new data types to provide better support for array data, and we want to test this and map these data basically to the OPC UA representation of array data. The fourth topic in regard to prototyping of FDT 2.1 is support for protocol-independent protocol support files. FDT2 had a protocol-specific approach for those files, and FDT 2.1 defines a protocol-independent approach, and this actually makes it easier for the OPC server to support these files. So we want to test implement this. Next slide, please. So the second priority topic was support of I/O data. I'm not yet seeing the slide, but basically the use case would be that the DTM provides a description of I/O signals. Okay, there's the slide. So as I said before, this is one of our high priority topics. So what we want to do is basically when the DTM provides the information regarding the I/O configuration, we want to expose this information to the OPC UA client. And then the OPC UA client may use this description as a base for accessing the I/O data. So the I/O data is basically support of I/O data is explained in the next slide, right? So the target here would be to be able to observe the production process or observe the device performance. So actually the base requirement is that the DTM provides access to the I/O data, and this can be done only via the device data interface. So only when the DTM supports access to the I/O data via the acyclic device access services, then we are able to support also this use case. And then the OPC server may map the data to the respective parameter nodes in the parameter set, and the OPC UA client may then access the I/O data. So this very much depends on support by the DTMs. Okay, so basically this would be the end of the presentation. Are there any questions?
I have a question for Michael Gunzert from the web.
Okay.
And what is the
Do
question?
you think it's feasible to use a web solution as a desktop client solution?
Yes. I think so.
Yeah, we think that will be the future, because normally you will then only develop one UI for your DTM, which is the HTML UI, and then you can use it in a desktop as in a web browser in the mobile device.
Okay. And then he has another question, and he would like to know a little bit more detail about performance and security issues that were mentioned as results of the prototyping.
Yeah. We did some tests regarding performance. What I said. So we had we set as a requirement this at least 200 milliseconds response time. So where we said, okay, this is the time where a user actually notices some delay. If you take some action, click a button or something, and nothing happens for more than 200 milliseconds, the user notices that there is a delay. And also we wanted to be able to get updates or events from a server at a time rate, at a minimum rate of at least 200 milliseconds per event. We said, okay, this should be enough to update any kind of graphs or something. And we found this is absolutely possible. So with by using WebSockets. It was slower by using normal REST-based web services, which was our first approach. Okay, so this was one consideration there. We did we made some thoughts also regarding security, but not in depth by now. So also there we got at least the impression, okay, with WebSockets we are on the safe side, because what other people, other experts told us, and we can use TLS as a secure transport layer. So we think this is a good way to go further.
But we think we have extra work on security to assess with some experts the architecture and to see if there are gaps which we have to close. So that the security discussion and the security work is not yet done.
Okay, those are all the questions from the web.
Okay, thank you. I'd like to just switch gears a little bit. We've looked through the technology and some of the technology stacks and decisions that are being made. So the board of directors, when they launched this project, said they agree wholeheartedly with the project. They thought the research to get the project defined was excellent by technology marketing. All that's good. But they did throw out one little issue in front of us, and that's if they're going to go ahead with this project, it's not going to be 3 years for development, 2 years for tools, and then we start rolling it out. That instead, it's got to be in the market, released as a specification, and certifiable through certification procedures by the end of 2018. Okay, which is an incredible speed by any of our project standards, by any other parallel industry association standards. That's incredible speed. But I hope if you just consider that only in October did we get the go-ahead to start this project, and as far as we are already, as Michael and Thomas have described it, great strides have been made. Obviously, we've got a long ways to go. We've had meetings this week, and they continue tomorrow yet, with the various committees that are responsible for parts of this to make sure that they're funded, staffed, and on a schedule to support what the board of directors has mandated. So a lot of work to go yet, clearly, but also a lot of wheels are turning right now to make sure that that happens. One of the things we are thinking of for a follow-up to this meeting, before I get into the technology stack, is we feel when we look at the rough timeline right now, that around March of 2018, we'll probably be in a position where we could have a developer's workshop where you'd actually come with the developer and code up a basic ETM, particularly the graphical user interface side of things, so that you could test the HTML5, JavaScript, WebSockets, connections, all those kinds of things, build up a basic DTM. This is much like what we did if you came to one of our first common component developer seminars, where you sat down with common components, and in that one day, you built a DTM for FDT2. Basic functionality, but it was a full working DTM. So we'd kind of like to repeat that with the FITS DTM. And at the same time, we think we could do it with a basic app. So we pick some development platform for an app, take advantage of the WebSockets, and create a basic app in the context of that developer's workshop. Probably a 2-day workshop, if we just kind of rough it out from where we're sitting today, and most likely somewhere here in Europe, just based on the typical attendance, but that would be decided. So all I ask is kind of keep it in mind. We'll lock in the dates as quickly as we can, certainly before the end of the year. We'll communicate the dates for you for this event and the location. So if it's you or developers that work for you that you want to send to this seminar, you'll be able to do that. Just like we did with Common Components, they'll probably have to bring a prescribed PC with the right development tools on it, ready to go, and then we provide the infrastructure and go from there. So we think that's a good logical next step so that you can get some hands-on. The spec won't be buttoned down. There'll be a lot of work to do yet, but it should be in pretty close form to what you'd actually build to in the end. Does that sound valuable to you as a group? Hopefully. Okay, good. Well, we'll work towards that. I want to just touch a little bit on technology stack issues because I appreciate, a lot of us almost live FDT day in and day out, and others have broad product responsibilities in your companies, and FDT is just one little piece of that puzzle. We hope an important piece, but we acknowledge you're not focusing on it every day. So we wanted to take just a little time to review where we are with these different standards and what the implications are of moving through these different standards, okay? So, thought we were going to do that. Here we go. So, this is a quick look, and these are highlights. These aren't every last detail, but this is a quick look at features and capabilities. If you start at about the 1.2.x time frame and bring yourself forward to FIPS. Okay, so when you look at it from the 1.2 side of things, we've got basically a single user desktop-based application, and it's built on ActiveX controls and a lot of XML and other things. COM architecture, all those things. Okay, that's the primary extent of its major distinguishable features. When we moved to FDT2, we added a lot of capabilities to the technology stack. So one of the things we had said with 1.2 that we recognized is when we built very large projects, the frame would bog down. It couldn't handle instantiating large projects, a lot of DTMs, and we had projects that were approaching, we had projects with thousands of DTMs in them, thousands, and you start to show your performance issues. One of the things that we changed to help that in FDT2 is we went from a single blob data storage concept for the DTM to allow the DTM to specify granular data storage. So just to put this in context, in the old standard, 1.2, if your DTM needed one value from the database, it had to take everything it was storing, read it into the DTM, find the value, and then if it changed it, it would have to write out all the blob again back to the server, to the frame. In FDT2, that was much more granular, and that was one of the major speed improvements. In FDT2, we added OPC UA. The interfaces were well enough defined in FDT2 to allow that. You can't do that in FDT 1.2. You can't get that capability. We recognize from the lessons learned with 1.2 that a lot of places where companies struggled was learning the darn standard. I mean, it's a huge standard. There's a lot of detail in it, but not everything is an exact written prescription for every little nuance as to how to implement it. And so many companies spend time spinning just learning the standard, writing state machines, doing all the other sorts of things, getting hung up on various parts of the standard. We recognize that, and we said, we've got to come out with a developer's toolkit that does most of that stuff. Why make everybody repeat it? And not only if we had a developer's toolkit, we could pre-certify that developer's kit so we could do away with a whole bunch of test cases when it came to certifying that product because they were already built in common components. 1.2. In 2, we also introduced signed frame. No, it's not been tampered with, and it cannot be denied who supplied that component. So the security got wrapped. We also brought in the client-server architecture, and that's been implemented by a few companies in large DCS-type applications where they have a single server under FDT2 and multiple clients. You can't do that with 1.2 because the business logic and the graphical user interface are all commingled. They're not separated. So there would be no way to build a decent client server on that old architecture of the DTM. Under 2, we offered WinForm and WPF type user interfaces selectable by the developer. And so we moved off of some architecture that Microsoft was clearly signaling they're walking away from. They're not going to support in the long run. Okay, so just from 1.2 to 2, you can see that the 1.2 technology has got a lot of gray hairs on it already. And it's getting more so as time moves on. We're going to start to have more and more platform problems as Microsoft moves along and so on. Plus, it's not responsive to some of the marketplace requirements. Now we come to FDT 2.5 or FITS. And we added a number of new features to it. So we're carrying much stronger security through the application. So you've got certificates that are sitting out there. You've got encryption of the communications, all leveraged off of industry standards. You add the apps to the top of that stack, and you add mobility to it. And then you develop in a more contemporary environment for graphical user interfaces. One thing we found was when we were talking with some of the companies about their future desires from the vendor perspective, that many companies have more HTML5 and JavaScript developers on staff than they have .NET. That the industry has moved that far along. So here, we're able to tap into a much larger talent pool in our vendor community to be able to develop these kind of apps. And it's certainly the direction the industry overall is going, is they're going to see more and more HTML5 and JavaScript type applications. So take a look at this graph in terms of where you are as a company developing DTMs. FDT 1.2 is by far and away our largest installed base. No question about it. The majority of stuff out there today is 1.2. And we still certify a lot of 1.2 DTMs every week. We're doing certifications of 1.2 DTMs. And I understand some of the market dynamics, it fits some of the installations, but nearly every frame in the marketplace has already been issued as an FDT2 frame as well. And so you've got the backwards compatibility, so you could be supplying FDT2 DTMs. I think now as we look at FITS, the gap is becoming larger and larger. So my caution to you is if you're still looking at 1.2 as a primary development platform, I think it's really time to look at your product roadmap and evaluate where do you introduce FITS. Because it's soon going to be at the point where 1.2 to the end user and to their expectations of performance, it's going to look somewhat archaic. Okay? Strong enough caution, hopefully, for everybody to spend a little time thinking about it. I recognize all the investments that have to occur to do that. I'm not trivializing that at all. I'm just trying to present a realistic view in terms of where the technology has moved in a few short years. Okay. Now, in terms of compatibility, I'd like to just do a few quick views of that. Here's 1.2 and 2.1 side by side, and whether it's 2 or 2.1 is pretty much the same for these talking purposes. On the left side, we've got our classic 1.2 frame. Okay, it's a desktop application. It can talk to all the control networks. It's based on ActiveX, so on and so forth. It is what it is. It works well. Today, on most platforms, we could continue to deploy it. We're starting to run into some platform issues, and we're trying to get over those where possible. Then on the right side, you've got the FDT2 or 2.1 type frames. Here we can host both a 1.2 and a 2.0 or 2.1 DTM in those frames. You can mix and match freely. But the feature set that the user sees is dependent largely on what the DTM is. So if you've got a user that's got this mixed topology with an FDT2 frame and 1.2 DTMs and 2 DTMs in there, and their use case is to start deploying OPC UA, there's a real problem. because the 1.2 DTMs cannot support OPC UA. Okay, so you start to see, where the issues will arise in the marketplace. We've done our best to follow the marketplace requirements, including things like OPC UA, web, apps, and so on, but you can't make those backwards compatible with the old technologies. We reach our limit every time with those in some fashion. So 2 is very deployable, mixed topologies, communicate to all the devices. I would say all the core functionality of FDT that people expect from its beginning are still there and work fine. One thing we can say about this topology, though, is it's slow. When you mix the DTMs in a frame, all the speed advantages that we got from doing FDT2 basically drop off. And you're back to the lumbering 1.2 type frame. So as you scale up a project in this mixed topology, it's not going to perform very well. It'll perform more like 1.2 did as you scale it up. Okay. Yeah, and just another limitation to consider. Even slower?
Because if you have to do the
transformations.
transformations.
The XML transformations have to happen. So just be prepared in that mixed topology. It's not going to be a speed demon. It works, but it's not going to be a speed demon. Okay, then if we go forward to fits. Now we're presenting 2 things here, but I want to be real clear on this, so don't run too far from this slide before you hear me talk. Okay, on the right side of the slide, we've got what Michael and Thomas just described in great detail to you. A server serving up DTMs to mobile clients and being able to run apps on those mobile clients and to connect OPC UA to those devices. That's FITS. Remember, the operative letter in FITS is the S. It's a server. Okay, it is a server. It is not a desktop application. It is a server. But we recognize, if you look on the left side of this graph, that it would be possible to build a more classic frame application where you could mix FDT 1.2, FDT 2, and 2.5 or FITS DTMs all in the same frame. It is possible to build such a critter. It will not be called out in the FITS specification how to do that, but I think to any experienced frame developer, the steps are fairly obvious. There will be some issues here, though, if somebody does this. First, you could say, well, I could offer mobile communications for those DTMs that are 2.5 in that frame. And that may be true, but if your motivation is you need to build this frame to have all this backwards compatibility, then that's not a very good leg to stand on. Because if you're deploying this frame because somebody needs all their 1.2 DTMs to work, that means the majority of their project structure would not work in a mobile environment. And from a user experience standpoint, that's almost unmanageable. Why is it this one DTM I can find and all the others I can't find on my mobile device? The value of that is highly questionable. Similarly, the performance of this thing is probably going to be even more of a dog because you're layering all this stuff and requirements into one frame. So, for example, when you need to instantiate the user interface of an FDT 2.5 DTM, you'll have to make sure the server's up, and then bring up a web browser within that same frame application to see that interface. Or through other means, but you can see you're starting to layer more and more into one frame application. So we bring this up just strictly as an example that it's possible. It will not be specified, but it is possible. But the use cases seem extraordinarily limited as to why you would do this. It might be if you had a client that said, oh, I just have to stay with 1.2 for a while, but I need some more capabilities. You might be able to justify it, but for the amount of work that would go into a frame to have these capabilities, I wonder if a vendor can justify the investment. Okay, so just be cautious. It's possible, but probably not a good solution. So that really points us to, just kind of summarize on this slide, it really points us to saying it is time to take the step from wherever you are in that continuum to seriously plan 2.5 in your product roadmap. It's where the marketplace is going. It's where the user base has clearly told us we have to get to support what they want to do. We just had a discussion in technology marketing earlier that because we can't offer a mobile solution today, we're seeing more and more of our own members coming out with apps for tablets and phones so that you can field configure their devices. Now think about the irony of this. Why did FDT get founded in the first place? It was because every vendor had their own software tools to configure devices and nothing was compatible, and by the time you got all those vendors' tools, you had a stack of CDs in your office that you needed a librarian to manage. If we're not careful, we're headed right back to there, and all we're changing from is CDs to apps. And we already can see that in the marketplace. So clearly the marketplace is demanding the FITS type solution. And before we go down the path of a stack of apps, I think we really have to get after the 2.5 development path. It's a much more robust path, it's much more capable, it's much more extensible, and it gives the one thing that apps never give, and that's interoperability. Apps by definition are non-interoperable. Any questions or comments here, or observations, or concerns? Katie, from your side on the web?
There's nothing from the web.
Oh, it's blinking red, so.
I don't think that's, We're seeing that maybe there's a comment, but you're not seeing anything, Katie.
No questions.
Okay, anything from this side, from the live audience? This make sense to you? Is it defensible in your companies? Because, we're not about writing standards just to have the fun activity about writing standards. We do this for the benefits of the membership, and you folks are the membership, so we want to make sure we're headed in the direction that you need it to go. For your customer base, for your products.
So if you are in the migration phase from 1.2, and you start moving to FDT 2.1, you advise us to maybe wait and make the step definitely to fit or...
Yeah, so the question is, let me repeat the question for everybody on the line. The question is, if you're currently at the 1.2 stage of DTM development, and you're looking now at 2.1 coming out shortly, which is really minor improvements to 2, just to be clear, some minor improvements to 2. There's no big feature changes. Should you do 2.1, or should you wait and do FITS? And we've got a number of technical experts in the room. Other people may want to chime in on this. My perspective would be that if you're sitting at 1.2, pick up common components for FDT2 and start going through it, because a good part of the transition to go from 1.2 to FITS is in the 2.0 specification already. Separation of business logic, all those things. I would say the point you'd want to cut off your development is when you start working on the graphical user interface. At that point, you should seriously be looking at 2.5. But almost all the other work, and correct me if I'm wrong, some of the technical experts in the room, almost all the other work that you would do to get to 2 will be reusable on FITS. Is that a fair statement, Michael and Ted? Yeah, I'm getting nods in the room. So that would be our recommended strategy for it. And look at the timeline of FITS. I mean, even if we're off a few months and disappoint the board a little bit, I never said that. But even if we are, that's still a pretty aggressive timeline, probably from where you sit today from a product development perspective. And so I think we'll be able to match your speed, is what I'm saying.
I agree.
Michael said it a couple of times, but it might not have really sunk in context of the question that was just asked, is all this prototyping work that Michael described is specifically written on top of common components. When we did FDT2 development work, now there was differences there, but when we did that, in order to validate prototypes and things, we specifically did throwaway code. We had a room full of developers where you could throw in, here's what we need prototype. They'd quickly prototype that thing, give it back to architect the specification, and they'd say, okay, it did what we wanted, or no, we got to tweak it, or no, that's not going to work, we got to come up with something else, and the code got thrown away. That was one of our lessons learned when the board said, okay, you're going to do this, but you're going to do it by 2018. We looked at how we did our development in the past and realized that even though you might risk in the end not being able to use some of that code, now that we've got a solid common component space to build from, and so much of it is actually part of FITS, as Michael reiterated several times, that it would be more logical to build on top of common components as we build these prototypes. So when we walk away from prototyping, we already have a good chunk of the work in the common components. Unlike last time where we actually started common components just as we were finishing the specification. So this is how we believe we'll be able to release the FITS version of common components at the same time as we release the specification. And we're doing the same thing with test and certification. We're paralleling that activity now so that the tools are ready to go and procedures are ready to go by the time FITS is released to the marketplace. Another thing I would suggest to you, just on the topic of how should I, if I'm sitting at 1.2, move forward, an area you might find very valuable is to join the prototyping activity for FITS. Because you'll have an opportunity. Michael mentioned several vendors who are taking some of their existing DTMs and upgrading them to FITS to test things and so on. But obviously, you get much more than testing out of that activity. You get firsthand personal knowledge and experience as to what's it going to take to get to FITS. So, if you're thinking about something like that, talk with Michael or talk with Tetsuo, our Vice President of Technology in the back, and let them know you're interested in jumping in with some prototyping activity on some of your products to gain some experience. And obviously the team benefits from your help too, because it's just that much more product that can be tested against prototyping and other activities. And you'll basically have a leg up in the marketplace because you'll have hands-on with FITS before most companies will. And you'll probably even help shape FITS a little bit because we rely heavily on those people that are participating to guide the final technology decisions. Any other questions or comments on this topic? You are generally a quiet group today. Anything on your side, Katie?
Not right now.
Okay. Well, this is the material we wanted to present today. So we've got our three presenters here yet. We've got Manfred here as well, and Tetsuo, and we've got technology marketing as well represented in here. So if there are any questions at all about the broader subject of FITS, where we're going, timelines, features you didn't see that you were hoping to see, anything like that, now would be the time to bring it up. One question from the room here, a comment?
And previously you talked also about solutions built on the cloud. Is there any plans to do some prototyping work?
I think we will. we haven't laid out all the next steps of prototyping. This first step was so fundamental to the overall architecture, we just had to get through this. But we will be laying out to the board another prototyping stage, probably mid-year to finalize any issues. We've started playing around with activities on Microsoft Cloud ourselves at the business office to get ready for some of this. We moved some of our applications up there, played around with scaling them up, scaling them down, some of those things. So we've built some internal experience. I think it's only logical that we'd want to take a fifth server, put it up there, and connect it to either our test lab, that we have all that equipment installed in, and play a little bit against that from a virtual location, something along those lines. This would also be an area where we have expertise with cloud-type applications, and you'd want to get involved with that phase, just let us know. Yes, Katie?
We have a couple questions online. The first is, will there be a prototype for a non-HTML5 based app?
Yes, I think we'll get there. That's what we hope to have at the developers seminar in March, to be able to author that using one of the more conventional tools. Michael's going to say something here.
Yes, somebody is going to do that.
Michael's looking for volunteers.
We will be doing one which is based on Android, native Android app.
So Michael said, just for those that couldn't hear it, they are doing a native Android app for the prototyping activity.
Okay. The second question, and this may go along with the first, I'm not sure, is essentially native framework or Xamarin?
Native framework or Xamarin is the question for apps.
For apps in general, you can use native frameworks, you can use Xamarin. That's all possible. Or what's the question? What we are going to use in the prototyping?
Go ahead.
So we have a native app for Android.
Okay.
So we are going to do for the prototyping.
Yeah, the general answer is anything that can support WebSockets from a development perspective, you should be able to write an app with it. We're using the native Android development tools for the prototype. But there's no prescribed tool set that you have to use to be able to build an app for FIPS.
Okay, that's all the questions right now.
Okay, then I have one last slide for you, just kind of food for thought, and it does relate to some of our activity and maybe even a couple of the questions that were just asked. And that's, from an FDT perspective, our membership is really vendors, and we really look to vendors for DTMs or frames, is primarily what's happening there. We obviously have some vendors that are very service-oriented as well, that'll help people with tools or develop products for them along those lines. But we are acknowledging that from a FDT organizational perspective, we may very well have a new group of companies that are interested in what we're doing that we didn't have before. And it comes from the area of apps. This whole issue of developing apps, if you follow other markets in terms of how apps are developed, there's a lot of stories about people, they always say in their garage or something like that, developing an app, and it's a really cool app, and it does a great thing, and they put it out on the App Store, and people start buying it. There really is nothing prohibiting a similar set of circumstances from happening with FIPS. The web services interfaces will be published as part of the standard. We could very well have some software company out there that says, hey, I've got a great idea for maintenance people that does this, 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 and this, and this, and I'm going to write an app to do it. So we may see interest from other areas. And we've talked about this in technology marketing and always talk about examples of what we mean. So I'll give you just a food for thought, kind of out-of-the-box app-type idea. Today, we know that our DTMs can tell us the health of the devices, whether they need service, attention, and so on. And the primary way to look at that today is look at the DTM. Some of the DCS applications have an asset management tool that helps with that. But under FITS, you could just as well design an app that was geolocation smart, so it knew where it was, knew where the device was at any time, either through GPS or Wi-Fi triangulation or all the other things that are out there on the market now. So it knows where it is. It's sitting in the pocket or on the belt of the maintenance person, and as they walk through the facility, if anything in that facility needs their attention, the app starts ringing them, vibrating on them. They pull it out, and it says, oh, asset 232 on this machine has got this condition. Oh, well, I'm right next to that machine. Let me go check that out. You take that to a maintenance manager or a plant manager and say, this is a $10 app or a $100 app for your maintenance people. What do you think the response is going to be? You know, if they used it 1 out of 10 times, I can guarantee you they'll have that installed on every mobile device that a maintenance person has. It's just a no-brainer. That's the kind of stuff that's going to happen with apps and FITS. The DTM will still be king in that formula because it's there providing the information, it knows about the devices, so on and so forth, but aggregating that information and layering new workflows along with it is going to open up whole new markets, both for developers and for the deployment of the applications, for the solutions that are possible with FITS. Some of this may interest your companies. I've talked to some companies that have a wealth of experience in asset management systems, like within DCS environments, those kind of things. And they're already saying, you know, some of this we could move off to an app on a smart device, and it would be so much nicer. So you're not looking at status boards and looking at LED tickers and things like that to figure out what's going on. It's right there in your pocket, and it's fed to you proactively. Okay, so kind of an interesting area to think about. We also see a possibility that somebody, to Michael's point about putting this up in the cloud, you could open up a whole new service model around this thing. So instead of the customer having to get a FIT server, get all the DTMs, get it all configured, and then let their people use it, somebody could offer that whole thing as a service. You could walk into a facility and say, you don't have to install anything. We just need a gateway to your control network that's agreeable to your IT department. We configure it for you. We'll be back in a week, and your maintenance people have access to all the devices. Your engineers can configure all the devices. It'll be done. And they'd sell that to you on a per device per month basis, or some model like that, some repetitive income model that drives their business model. And again, this might be something that you as vendors could even envision. If you already have frames and some success with frames, I think a service model around a FITS instance would be quite attractive to many customers. It's the ultimate cloud. I don't have to do anything. Ultimate cloud. I just turn it on and pay the bill. Kind of neat, huh? Other areas that we could see that people would be interested in, integration to ERP and CMMS is a big space, and whether they do this with OPC UA or whether they do it with our WebSockets capabilities, that's for them to decide. I think most of that would go the OPC route just logically, but there's a service model there as well. Just because you have OPC on both ends of the hose doesn't mean they're ready to just start exchanging data freely. Work has to be done there. And there's definitely a service layer in there for some company that's interested to do that kind of work. Same with, even if you're just integrating into a computerized maintenance management system, there's some integration work that has to go on there. So another service model possibility. So we just wanted to bring this up to kind of get your wheels spinning. We are looking at certifying apps. So just like we certify DTMs today, we'd like to have a path to certify apps. So we do things like check to make sure they're exercising all the WebSocket interfaces correctly, that they're following the security models, some of those kind of things. We wouldn't care about the actual functionality of the app. We'd be more concerned about where they interface with our standard, and we'd certify to that. Any questions, comments, or other ideas there, maybe? Yes, go ahead.
As far as I learned so far, all is starting with a topology already being defined on the FIT zone, right?
It does not have to be. The question is, are we starting with the topology already defined on FITs? You would be able to, with a FIT server, configure the topology online as well.
Okay.
You wouldn't have to start it somewhere else and import it.
So we can use the app or whatever to define the topology on the FIT zone.
Yeah, you'd probably use, what that would probably look like, and correct me if I'm wrong here, Michael or Ted, is it would probably look like just another web interface, so you'd have a browser that you're doing this on. And in this case, the GUI for that is coming from the frame itself, not from the individual DTMs. So you still have the need to browse a project structure and do other things like Michael showed you. That's actually coming from the old frame part of it, now a server. Same thing with building a topology.
Because I was thinking about a maintenance use case for device exchange, so that will be possible.
Yes, yes. Yeah, the question is, would a use case of a maintenance device exchange be possible? And the answer is yes. Yeah. As we said, we're supporting all of our existing use cases, especially any maintenance-related use cases will be supportable with FITs. And new use cases as well for maintenance. Anything from the line, Katie?
No questions right now.
Okay, well, let's wrap it up. I think we made good use of our time here today. We're done a little bit early, which is always a good thing. We will get back to all of the participants, whether they're in person or online, with a link so you can replay this entire scenario if you want to see it in audio form and watch it again, or maybe somebody in your staff wants to see parts or all of it, so you'll get a link for that. We'll also give you a link if you want to just download the PowerPoint so you can reuse it within your facility. At this point, remember, all the information is designed strictly for members of the FDT Group. We're not far enough along to be able to make it public information and have people that aren't in regular contact with us start developing product. We know with our members, they know where to come with questions. Outsiders may not do that. So that's why we restricted this to members only, and I'd ask that you continue that with the information you receive as a follow-up to this. It was mentioned that on our website is an upcoming OPC UA webinar that's held jointly by the OPC folks. Tom Burke and I are sponsoring that. Thomas Vesters will be one of the primary speakers on that. They'll drill further into what's going on with OPC, UA, and FDT. Thomas Hotlick. I was looking at Thomas Vesters and said that. He was wondering where he picked up a seminar to go to. Sorry. Dr. Thomas Hotlick is going to be the main presenter on that one. So look for that one if you're interested in more OPC UA. And then we'll also follow up with you as soon as this date is set for a hands-on FITS developer seminar. We'll get it to you so you can get those dates blocked off on your calendars and be able to assign yourself or staffs to it as appropriate to attend that. So thank you very much, everybody. With that, we'll conclude both the online and in-person seminar. Thank you, everybody.